Hi, in this lesson we're going to have a look at volume. We've studied area and perimeter of shapes. These are all two-dimensional features, flat shapes. We're going to have a look at cuboids first of all, which are the kind of effectively the most simple of the three-dimensional shapes we can look at. The volume of a shape is the amount of space that shape contains. It might be a solid shape, so the space inside might be made of something, or there could be just air inside, so it could be a hollow shape. There could be liquid in it. So it's not about what's in it, it's about the actual amount of space it takes up. And just like we did with area, we can start off area by kind of counting the number of boxes that would fit inside a shape like a square or a rectangle. In terms of volume, we do the same, but this time because we're thinking about cubes, which are the three-dimensional versions of our squares. So if we think about a cube having a square face, if we think about this cube on the left-hand side here, each of the dimensions of the cube is 1 centimetre. So we say that the amount of space that takes up is 1 cubic centimetre. Okay, there's an interesting thing, and it's always an interesting point, because when it's square or cubic units here, we always put the number after the units, like centimetres. So here it would be very easy to read it as 1 centimetre cubed. Okay, when you're actually reading it out loud, we usually say 1 cubic centimetre, just as we normally say 1 squared centimetre, even though the number's at the end. Okay, I've misspelled that, haven't I? It should be RE. So that's just a little bit of a note about saying these units, and you'll hear me say cubic centimetres rather than centimetres cubed. So that would be the unit of volume for shapes where we're dealing with centimetres as our dimensions usually. We can do the same with millimetres. Here we've got a much smaller cube, which would have a volume of 1 cubic millimetre, and a very much bigger shape that has the dimensions of a metre on each side, and the volume of that would be 1 cubic metre, much bigger. And it depends on the shape and the size of the shape that we're dealing with. So let's have a look at the idea of volume. So the most basic idea, just as we can count squares to work out area, we can also work out volume by counting cubes. Okay, so that's the first thing we're going to do as a little kind of starter activity. So on the left hand side are some cuboids made of cubes, and we can hopefully, you can see that they're made of three-dimensional cubes. So just watch that, of course, this, see the bits here, that's just the side of those single cubes there. So that's just a wall of cubes 1 deep, whereas some of the shapes are 2 or 3 cubes deep. So the starter activity here is to work out the volume of each of these shapes just by saying how many cubes make them up. If we're saying that each cube has a length of 1 centimetre, it means that the volume of each is going to be indicated in cubic centimetres. And if you have a go at that, if you feel brave enough, you can have a go at trying to work out the volumes of each of these blocks. And also the fact that you might get a different answer from me for some of them, depending on what you think is going on in the shape, because there are bits that we don't really know what's going on when we're not able to view the shape from lots of different angles. So I want you to pause the video, and I want you to work out what the volume of each of the shapes on the left hand side are, and if you think you can, have a go at the volume of the right hand side shapes as well. Okay, pause the video. Okay, so hopefully you've had a go at that, and what we can see here are the volumes of the shapes as I have seen them. I'll just bring that up so it's in the screen. So, do you agree with me? How did you work them out? Well, you might have tried to count them all individually, or you might have developed a pattern. You might, for instance, have worked out the number of boxes in the kind of wall at the front, and then just multiplied that number by how many deep there were, and that's absolutely fine. Different ways to work it out. That's how we might start with the volume of cuboids. Okay, if you tried the other ones, then well done. These are the answers that I got. The assumptions that I made, for instance, were in the first question, even though I can't see in here, even though I can't see round here, I'm assuming that the pattern is the same in all four sides, and that there's symmetry here. I can't see the fact that there's a little step, but I'm going to assume that that's the case. It might not be. You might have decided that it was just straight down in those sides, and you would get a different answer. With this one here on the right, what I assumed was that the hole in the middle only went down to those four boxes. So I assumed that the hole didn't go all the way down to the ground. But you might have, in which case your volume would have been 2 less than mine. Another one was this one here. I assumed that there was only a hole in the top and that the rest of it was solid. You might again have thought the hole went all the way down, so you wouldn't have got the same. And here, I did assume in the bottom one here that the hole went all the way down, just because, I don't know, it's just the way I interpreted it. So we can see when it comes to some more complex shapes that our answers might be different if we don't have a number of different views of the shape, or we don't know enough information. Okay, so that's a wee activity about volume where we're counting cubes. How can we look at establishing rules though for some of the standard shapes like cuboids? So what you did with that starter when we were working out the volume of a block like this was you could have tried to think about it in entirety, but we can't see all the cubes, so you would have had to come up with a rule or a pattern. So we can count the number of cubes on the top, 1, 2, 3, 4, 5, 6. And you might even have said, well, if there's 6 cubes there, there's 4 rows of 6, so straight away I know that it's 24. So we're thinking about the volume as being something to do with 24, because that's 6 times 4. But we've still got to say there's another row here. This row here is another 24, and this row here is another 24 cubes. So in other words, we're saying that there's 3 lots of 24 in the volume, in which case that 6 times 4 is 24, multiplied by 3 would be 72 cubes. Okay, so what we've done there, we've actually just taken the 3 dimensions, the number of cubes. There's 6 cubes along this side, there's 4 cubes along that side, and there's 3 cubes up and down. We've taken these 3 dimensions and we've multiplied them together, and that gives us a number of cubes. And that happens for all cuboids. That's why it's the most straightforward 3-dimensional shape to think about volume. So here we go. The volume of a cuboid for any cuboid is simply the 3 dimensions multiplied together, and we usually give them a kind of length, breadth and height name, and therefore we get this formula, V equals L times B times H. Okay, so it's good to copy down just to have as a note to say this is a standard formula that we're going to use. Sometimes you see it written down without the multiplication signs in between, so you might see V equals L B H, and that's fine. You can put the multiplication signs in if you want. It's a formula, so anytime you're working out the volume of a cuboid, I'd like to see that written out first of all, just like you do for the area of rectangles or triangles or anything. Always write it out. Okay, so let's apply that and see what we can do to solve these problems. First of all, I'll demonstrate this one and calculate the volume of these cuboids. This one on the left hand side is 10 by 8 times 5. It doesn't really matter which one you would call the length, the breadth and the height. The length is usually, and the breadths are usually kind of horizontal lengths, and the height of course usually goes up and down, but it doesn't really matter. You're going to multiply all 3 together. So we can say here we want to work out the volume of a cuboid, so I'm going to write down V equals L times B times H, because I'm telling anyone who's reading it that's the rule that I'm using. So it's really important that you communicate that. And we've got capital V for volume. That's okay. Then we're going to substitute, as we always do, into formulae. We're going to substitute in the numbers. We've got 10 multiplied by 8 multiplied by 5. And you can maybe do that in your head all the way, or you can do it bit by bit. I'm going to multiply 5 times 8 first of all is 40, because then it's easy to multiply the answer by 10. So I get 400. but if you want to write out any multiplication calculations to help you, then do so. So 400 is the answer. I'm dealing with centimetres, that's my unit of measure, so I'm going to be imagining that really we're talking about I can fit 400 centimetre cubes in this box, and therefore we indicate that by putting the wee centimetre 3. So I call it 400 cubic centimetres, even though I write the 3 at the end. Okay, now pause the video if you want, you have a go at doing this other one, and then you can see if you agree with mine. Okay, so it's a cuboid, and we're going to use the formula V equals L times B times H. V equals, put the 3 dimensions in, again, doesn't matter which way round, 3 times 4.5 multiplied by 2. You could use a calculator for that if you don't like the decimals, but have a look. 2 times 4.5, 2 is even, so twice 4.5 is 9, and that leaves me with 9 multiplied by 3 is 27. So there are strategies that you can use to solve it without a calculator. The units were in this shape here are in meters, so my volume units are cubic meters. So the volume of that cuboid, 27 cubic meters. So when you practice working out the volume of a cuboid, that's the 3 lines at the very least I'd like to see, with any supporting calculations at the side. Okay, so let's take it on a wee bit and think, well, if I've got the formula, could we work back? Could we work out the dimensions if we know the formula? Well, sure we can. So it says calculate the missing dimensions of these cuboids. So this time we've got the volume, and we've got a length of 5 millimeters, a depth of 6 millimeters, and we're kind of missing the height. So I'm going to write in H for height here, and that's what we're trying to work out. So what do we have to do here? Does that mean we can't use the formula? Well, it doesn't. The formula, remember, is the rule that connects the volume to the length and the breadth and the height. So we still use that. That's why I always ask you to start with it, because not always are we going to work out the V part. So this time we can still substitute in what we know. This time we know the volume's 120 cubic millimeters. Have a look at the other dimensions. They are millimeters as well, so that's okay. The length is 5, the breadth is 6, and this H is unknown, so I'm going to put in H there. So how do we solve that? Well, I would be working out what 5 times 6 is, first of all. Oops. So we've got... Oh. Okay, let's get rid of that. Okay, so what have we got? We've got 120 is equal to 5 multiplied by 6 is 30 times H. Now remember, in algebra we sometimes don't even put the times sign here, so 30H would be fine. And we know that if we've got something multiplying a letter and we want to solve it, we just do the inverse operation. So if I want to undo or cancel out the times 30, all I have to do is to divide both sides by 30. And that leaves me with H on the left hand side. I've got H on the left because they cancel out, and 20 divided by 30, 120 divided by 30, divide through by 10, 12 divided by 3 is 4, so in actual fact the height of the cuboid is 4 millimeters. Okay, there we go. That's us using the formula in a slightly different way. If you want to have a look at this one, have a go at it yourself, you could pause the video or you can work through it with me. So we've got a missing dimension here. Which is a missing dimension? We've got the breadth is 12, the height is 18, so technically that would be the length that we're short of here. The volume is 2,592 cubic centimetres, and that fits because all of our other dimensions are centimetres. So let's write down the formula. V equals L times B times H. So there we go. So what do we know? We know that the volume this time is 2,592. That goes on the left with the V. L we don't know. The breadth is 12 and the height is 18. So we don't know this number here. Again, what I would do is I would work out this number here, 12 multiplied by 18. You could use a calculator, or at the side, I could do 2 times 8 is 16, 2 times 1 is 2 is 3. I'm going to multiply through by the 1, which puts a 0 there. And I'm going to start under the tens, in the tens column. 1 times 8 is 8, 1 times 1 is 1. I'm going to add these two together, and I get 216. So I've got 2,592 equals 216L, or L times 216. Well, in terms of algebra, in order to get L on its own, I'm going to divide both sides by that multiplier, so they cancel out, and I get L is equal to 2592 over 216, which I'm not going to do a long multiplication, a long division calculation. I could start to simplify the fraction. In this case here, I'm going to reach for my calculator. 2592 divided by 216 gives me 12. Okay, I could have tried to simplify the fraction and that would be fine, but just to save a bit of time just now, we're going to go with 12. The units are all centimetres, and there for the length of that dimension is 12 centimetres. Okay, so that's how we would use the formula working back as well. Hopefully that's been helpful. Practice on working out the volumes and dimensions of cuboids.